So I have right here two very similar plastic parts that are 3D printed. One was printed in this orientation, so it was built up toward the camera, but it had a lot of surface area on the bed. And then this part here was printed in this orientation, and they were all printed in the same batch, but this one was printed with much smaller surface area on the bed. Anyways, under some circumstances, these pieces would be usable for the same purposes. Like, say if I was putting some sort of mass on top of these, right? They would probably be fine. And arguably, let's say, arguably they would probably still be okay-ish in some sort of compression here. It's when you start having stresses in this direction, where this side is fixed, that the orientation can become important. So, for example, right, this is the piece that was printed with small layers building up. So there's several layers. This one only has like 15 layers essentially. Anyways, so this one that was printed with a bunch of small layers, we call them layer lines, are on this axis here. And watch what happens, right? If I try and break this guy, it just snaps, right? And you can see the infill structure in there. It's not solid, which doesn't help it obviously, but yeah, so I was able to break it, and if I were to get out a microscope, I'd probably find that I was right on the layer line for most of that break. So right on that layer border from one layer to the next layer, that's where it peels apart, because that's the weakest part of a print typically. Anyways, so I go to my part that was printed like this, and I know this isn't a super scientific test, but yeah. So putting in, I was putting in more force even than with this guy, and it's not breaking. But yeah, so the biggest thing is that you are weak along your layer lines, and so that's something you need to be considerate of, is where your forces are going to be, and what direction they're going to be relative to your layer lines. So